Welcome to an introduction to functions of two variables. A function z equals f of x comma y is a function of two variables. The domain is a set of all possible values of x and y, or the set of all possible inputs, and the range is a set of all possible values of z from the domain, or the range is a set of all possible outputs. The graph is a set of all possible points x comma y comma z produced by the function. Geometrically, the graph is a surface in space. Let's look at some examples. Here we have four functions of two variables, and notice how in each case the graph is a surface in space. So we get some very interesting surfaces when we graph functions of two variables. Let's look at some applications of functions of two variables. Here we're given the cost C of d comma m in dollars for renting a car for d days and driving it m miles is given by the formula C of d comma m equals 40d plus 0.15 m. So d is the number of days and m is the number of miles. So for part A, we're asked, what is the cost for renting a car for 3 days and driving 200 miles? So for part A, we want to find the value of C of, again, it's d comma m. So we have 3 days and 200 miles, so C of 3 comma 200, which is equal to 40 times 3 plus 0.15 times 200. So notice how we substituted 3 for d and 200 for m. Let's go ahead and find this function value on the calculator. So we have 40 times 3 plus 0.15 times 200 is equal to 150, which means it costs $150 to rent a car for 3 days and drive 200 miles. For part B, we're asked to determine C of 100 comma 4 as well as C of 4 comma 100. So first, C of 100 comma 4 would be equal to 40 times 100 plus 0.15 times 4. So notice here d equals 100 and m equals 4. So this function value is going to be how much it would cost to rent a car for 100 days and only drive it 4 miles. So 40 times 100 plus 0.15 times 4 is equal to 4,000.6. So we have C of 100 comma 4 equals 4,000.6, which represents $4,000.60, which is the cost of renting a car for 100 days and driving 4 miles. So obviously this isn't very practical, but that's what this function value means. And C of 4 comma 100 would be equal to 40 times 4 plus 0.15 times 100. This will represent the cost to rent the car for 4 days and drive 100 miles, which would be much more realistic. So we have 40 times 4 plus 0.15 times 100, which is equal to 175. So this tells us that it costs $175 to rent a car for 4 days and drive 100 miles. Now let's answer part C on the next page. Part C says, suppose we rent the car for 3 days. Is C an increasing function of miles? So if we rent the car for 3 days, we know d equals 3. Let's take a look at the function C of 3 comma m. This would be equal to 40 times 3 plus 0.15 times m. Simplifying, we have C of 3 comma m is equal to 120 plus 0.15 m. And notice how as m increases, the total cost increases, so the answer is yes, C is an increasing function of miles. Notice how if we had a minus sign here instead of a plus sign, C would be a decreasing function of m. And I also provided the graph of C of d comma m here on the right. This would be a plane in space. Let's look at one more example. Here we have the Cobb-Douglas production function P of L comma k. Notice how once again we have a function of two variables where the inputs are L and K and the output is P of L comma k. We're asked to find the units of production when L equals 20 units of labor and K equals 11 units of capital are invested. And we're asked to give the answer to the nearest whole number. So we want to find the function value P of 20 comma 11. So we'll substitute 20 for L and 11 for K. So we'd have 25 times 20 raised to the power of 0.8 times 11 raised to the power of 0.2. And now we'll go to the calculator and round this function value to the nearest whole number. So we have 25, then in parentheses we have 20 raised to the power of 0.8, right arrow, and then in parentheses we have 11 raised to the power of 0.2. Enter. Rounding to the nearest whole number, we would round to 444. Which means that total units of production with 20 units of labor and 11 units of capital is 444 units. Now we might argue that we should have truncated rather than round up, meaning we might argue that we should only have 443 units of production, because going back to the calculator, notice how the production does not reach 444, but our directions did say round to the nearest whole number, which we did do. So maybe they'll decide to invest a little extra labor or a little extra capital to make that last unit. I've also provided the graph of our Cobb-Douglas production function given here. Notice how it would be the surface in space. If you want to learn more about the Cobb-Douglas production function, you may want to pause the video here and review what all these variables represent. But this production function is often used to represent the relationship between physical capital and labor and the amounts of output that can be produced by those inputs. I hope you found this lesson helpful.